Okay, so conservative forces are where they're path independent, such as gravity, the electrical force, and other things. So now, what about non-conservative forces? Well, that would be friction, tension, anything where the path that you take changes the amount of energy that you get out of it. So, such as if I am in a car, if I take a longer path, the air friction is going to have more force against it. Now, both of these can do work. The work due to conservative force and the work due to non-conservative forces. But this is everything. Something's either a conservative force or a non-conservative force. So together, that becomes the total work. The total work is the amount of conservative forces, work done by the conservative forces, and the work done by the non-conservative forces. What does that mean? Well, these words, what do I know about the total work? It changes kinetic energy by the work energy conservation theorem. But there aren't very many conservative forces out there. Oh, yeah, there is a handful. But if we move this around a little bit, I'm going to subtract conservative forces from this side, conservative forces from this side. So now I end up with non-conservative forces equal the change in kinetic energy of the system minus work done by the conservative forces. But if I only think about gravity, then this becomes the change in kinetic energy and the conservative force from earlier. This is the minus the, what was that, mg h initial minus h final from my gravity. Let's do a little bit of math here. Change in kinetic energy minus mg h naught plus mg h final. Move this into the change in kinetic energy. Move this around a little bit. Plus mgh final minus mgh initial. There we go. That looks a little bit cleaner. This becomes the change in kinetic energy plus this change in gravitational potential energy. That is, non-conservative work changes the kinetic energy or the gravitational potential energy. But if there's no friction, well, there's no tension. Well, the tension's gone. And we're talking about frictionless environments. If non-conservative work equals 0, then 0 equals the change in kinetic energy plus the change in potential energy. This is called the total, this is called the mechanical energy, because this is energy of motion and energy of position. The change in energy, now we have the conservation of energy law.